Our key speakers today are Alan Ambler. Come on, Alan. Hello there. And
Good to see
Steve
you, Pete.
Bredemeyer, a key person at Core & Main in the Midwest. Steve, tell us a little bit about who you are and what you do at Core & Main.
Well, I wish you would tell my boss that I'm VP of engineering. I might get a raise out of the deal. So I'm a regional sales manager for the central region for Fusible for Core & Main. So I'm leading our initiative to drive Fusible growth in the 5 states that I cover for the company, and been in the waterworks industry for, oh, it's sad to say, 32 years, I believe. Started in the bell and spigot pipe realm and have been in the HDPE world for 20 years now. Yeah, 20 years now. So
you were one of my early mentors. Thank you to you for sharing a portion of what you know about polyethylene with me when I got my start. So you're quite the resource. And thanks for coming on today to talk. And then Alan Ambler, give us a little background on you and what you do in the polyethylene world.
Okay, Pete. I talk to people like you and everybody out there in the interwebs quite a bit here. So I did run a municipality for almost 10 years. The utility manager, so managed the utility for the municipality, city of Castleberry, just north of Orlando, Florida. Now I talk about high density polyethylene quite a bit with lots of people that are interested to talk about it. So we love talking about polyethylene. Make sure you talk to us about it. We'd love to hear about your project. So a poll just popped up. If you've got a couple of minutes, please answer that poll for us. Gives us some good information. And if you're like me, and you happen to be a professional engineer that's getting your PDHs right now in Florida, the deadline is the 28th. This webinar will provide that, but it's important to get it quickly. Need to stay on and complete the survey at the end of the webinar here, because then the results of that survey are queued right to the person that'll make sure you get that PDH as soon as possible. If you send Dan an email, he'll have to sort through about 250 emails to try to make sure he gets it to you. So if you're like me, we're waiting to the last minute, of course, trying to get those PDHs, but we are so glad you're here for us. So,
okay. So today, just some a little bit more housekeeping. Go to the next slide, if you don't mind. We have several hundred people on this call. The purpose of this deck is to talk about some of the things that we've learned about how utilities integrate the product and the lessons that they've learned along the way. So if there's a slide in here on a topic, it's one that we think it's important for you on your journey as you advise municipalities, and if you're an employee in one, and how you operate in that space. So yes, we offer PDHs and CEUs. Wait till the end. We'll go Zoom off and the questions will come on. You answer the questions and then tell us exactly what you want. This is a 90-minute webinar. Yesterday, we kept all but about 8 people on to the end of the 90 minutes. Got a lot of great content, a lot of great videos. And with that, take a look here, copy down some key email addresses, take a snapshot of this page. It'll show up once more time at the end of the deck. Who's up first, Steve or Alan?
I believe I am. So
awesome.
Here we go. We'll go right into exactly how to integrate HDPE into your water system. So I'd like to spend just a couple of minutes at the beginning again. What exactly is a water system? And then what conditions do those municipalities out there face? AWWA, ASCE, all of these agencies have published summaries essentially of the condition of the infrastructure. Quite a bit of infrastructure was built after the Second World War during suburbanization of America as everything pushed out. And we're taking a look at exactly what the scope of the problem is in buried infrastructure and how much work we have to do. So recently, buried no longer indicates that I'll have $1 trillion over the next 25 years that'll have to be spent to be able to keep up, repair that infrastructure. It is costly. Essentially, we're looking to technology in order to be able to breach some of that gap. That was a separate EPA study. And we're not installing pipe the way that we used to as well, which is why high-density polyethylene continues to be a sought-after material of choice to be installed through trenchless technology methods or other new unique methods. So ASCE, similar report card here. Those of you who have kids out in the audience, if your kid was to come home with a C- or a D on the report card, we'd want immediate change. Same thing here with the infrastructure. Let's get some change. The good news is it has been inching up. The last time this report card came through over a decade ago, infrastructure for buried water mains was a solid D. Now it looks like it's a C-. So interesting to note here that there's a water main break every 2 minutes. So that could be small breaks up to very large breaks, which have obviously much higher economical impact, social and environmental damage through a break as well than a small one. HDPE is a leak-free product, so when installed correctly, we won't go through those leaks as well. So we'll start with some buried infrastructure utility maps. Some agencies are better than others as to the map or the mapping system as to which they know where all that existing pipeline is. They can be translated subsequently to an ArcGIS, which is a database combined with a mapping system that provides and houses intelligent information about the infrastructure asset within your overall system. Those ArcGIS systems have gotten so popular and so useful that they can actually replace the set of atlases or water maps in the truck. So that way the DNC operator can be out in the middle of the night with a tablet or something like that to pull up exactly where that pipeline infrastructure is. So again, these give us all sorts of information about profile, if we're lucky, changes in direction, changes in vertical, and all sorts of other things for us. So then it continues to grow and be a benefit when we overlay those into aerial maps, and we can make the direct correlation with above ground features and makes it easier to locate at that particular moment. Distribution system quality, and I'm sorry for the bottom right video for anybody that might be eating at this time. That is a potable water system with the bituminous liner failure. There's flow within the pipe, and that bituminous liner is just coming off and floating in that flow. So we do purge poor water through flushing, either unidirectional flushing, which is a focused direction to where we actually change and control valves and flow to purge contaminants out of the distribution system or debris, other things of that nature, which you'll see in the middle photograph there. Metallic pipes do corrode, and they will form a tubercle, which you'll see in the top right photograph. And basically that corrosion is that unuseful, non-structural metallic material that comes off of the pipe wall and allows space behind it for other things to corrode as well. One of the main reasons why we maintain a disinfection or chlorine residual within a system is to be at the farthest extents of the pipe networks, we still have that chlorine that can disinfect or neutralize anything that may be contained within the potable water system. So those tubercles oftentimes can hide a biomass or a biofilm, and that's one of the main reasons why it is that we keep chlorine at the full extent of the distribution system. So these pipe networks are rather complicated, lots of parts and pieces to it, storage tanks to make sure that we have enough water for those main events such as firefighting events, or in the event of a very large break. Obviously there's still going to be water in systems, so we make sure that the volume of water that we have is suitable for the system that we're looking at. Pumps, or the pumps can be variable speed drive pumps that will maintain similar pressures as a pressure tank, elevated pressure tank, to be able to make sure we're providing a continuous pressure through that. valves, fire hydrants, mainline pipes, all the various parts and pieces that are necessary to distribute the water from the main source after it's been treated all the way to everybody's tap. So there's lots of different things that as a municipality, you have to consider, especially when you're trying to adopt a new pipe product. So we're going to try to make sure that give you as much information and cover that as possible. Is it highly likely or possible that an established system such as the one we've talked about and analyzed in ASCEs, AWWAs, buried no longer can be 100% polyethylene? That's a very long journey, but we do appreciate that you're taking the first step about learning about polyethylene and how to integrate it by attending this webinar. So firefighting demand, as I said, is the largest demand that the distribution systems could potentially see. So in many instances, they'll have multiple fire hydrants fed from multiple directions and pipe networks to try to provide that fire fighting power. Historically, interestingly enough, one of the other largest demand events that happens is a cultural event and is occurring this Sunday. The Super Bowl actually is one of those events where you'll see most of the demand. So water main failure doesn't happen on a Tuesday at 9 o'clock after you're finished your coffee. It's going to happen on Sunday when that high demand is happening there. So when you're at the bar looking at the Super Bowl here, make sure you thank an operator mentally. Okay. So distribution pipe doesn't fail. Sometimes HDPE doesn't have those corrosion issues that lead to leaks. Those things sometimes can in other pipes, as that failure goes and continues, it could lead to a much larger collapse, which has a much greater impact, similar to what we'd see here in this animated GIF we've got for you there. So by employing HDPE as a leak-free system, now we're going to solve some of those problems with leaks that eventually lead to larger failures as we go through. So for your main lines, open cut construction is a way to be able to replace that existing pipe or install a new pipe for you. AWWA M55 manual has a design window, and essentially that design window is for pipes DR7 through DR21. If you have greater than 3 feet of cover for H20 loading, 2 feet of cover for non-vehicle loading, and less than 25 feet of depth, you don't have to do any calculations whatsoever for that. What you're seeing here, and I show this video a lot, installing high-density polyethylene, which is considered a flexible pipe. Ductile iron and cast iron are also considered flexible pipes when it comes to pipe installation. We want to make sure that the pipe stiffness works with the soil stiffness to provide, to distribute the load, any earth load or live loading or surcharge loading on top of that pipe to the soil surrounding that pipe. So this image here has all of the structural elements that you need with a good foundation that's free of rock, good bedding. So that's a soft place for that pipe to be able to go through. And then they will put the backfill back and make sure that it's properly compacted. This video, we don't have to have anybody in the trench, which is a much easier trench to be able to dig. We're taking advantage of that long fused run itself, and then they will backfill using machine techniques on top of that pipe as we go through. So this is a perfectly good, acceptable manners to installing that high-density polyethylene, and it's very productive. For horizontal directional drill, this is kind of the gateway drug for municipalities that have not used polyethylene previously to be able to have an introduction to polyethylene. There's a brilliant engineer that said, well, heck, if we're using it for the really tough stuff, why don't we use it for everything? Well, that's pretty smart, Louis Hamel. Definitely recommend using high-density polyethylene in that manner. So what we're trying to look for as designers for horizontal directional drill is to make sure that the entrance and exit angles are within the appropriate limits set by the equipment, not by the pipe. The drill string is oftentimes less flexible than the high density polyethylene. And then we'll watch that friction forces around when we get down to the proper curve where we're going underneath something, and then that friction force on the other side of the curve where we're coming up. So we want to make sure that that does not surpass the tensile strength of high density polyethylene. If you're interested, the Alliance does have spreadsheets for both up and open cut construction and horizontal directional drill, just in case you want to be able to work with us to evaluate your project. That's certainly meriting an email to myself or Dan Landy, dlandy@pepipe.org, if you'd like to be able to see those. We'd ask a couple of questions about your project and make sure that we steer you in the right direction to do it. Peter earlier mentioned pipe bursting. Pipe bursting is a trenchless technology. It's the only trenchless technology that can put back a larger OD pipe than the existing pipeline. So pipe bursting is doing three things simultaneously at once. It is fracturing that existing pipe, pushing it into the 2 to 3 inches of soil surrounding that pipe, creating a temporary soil cavity, and then pulling that replacement pipe back into place at the same time. Really cool technology. If you are limited in your as-built or your documented information, but have some good line work as to where that pipe could be, pipe bursting may very well be just right for you, because we are taking advantage of the fact that we have a proven conduit location that is free and clear of third-party utilities. Sometimes we can work off of less design details than full topographic survey and the whole 9 yards. But risk tolerance is unique to each individual owner, and you have to understand your owner, and they have to understand the process to be able to use that route. So at some point in time, the Alliance will offer a full-blown pipe bursting webinar as to which you can learn more about it. We might have a video or two about that on the website as well. So very proven technology, eliminates quite a bit of restoration, as it's 85% less excavation. And in suburban and urban environments, that restoration can cost a pretty penny. So anything that you can do to reduce that's going to be much better. Slip lining. Similar process and setup as we would for pipe bursting. The only difference is we are not fracturing that existing pipeline. So this is perfect for pre-stressed concrete cylinder pipe or other reinforced concrete pipes that simply cannot be burst. Large diameters, when we take advantage of the fact that we're fusing long runs in advance. In transmission mains, there's separation between valve to valve spacing that is much farther than in distribution mains, and we could probably get a significantly higher amount of productivity into place. We want to make sure that the interior diameter of that existing pipeline is properly prepared, so we're not pulling this replacement high-density polyethylene against some type of obstruction that'll stop the advance of what you're doing. So if you've got one of those pesky metallic pipes, then we'll have to scrape the inside of that to remove all that tuberculation that you saw before, and make sure that that exits the pipe as before we're prior to pulling in for slip lining here. There's a really cool technology. It's called compressive fit slip lining. So it only uses high density polyethylene, similar to pneumatic pipe bursting, which only uses high density polyethylene. But we'll take that OD of a HDPE pipe, put it through a die or series of rollers, and make it smaller. Now, of course, that pipe pulls and stretches. The behavior of high-density polyethylene that allows this process is called viscoelastic behavior. We did a whole bunch out of it on yesterday. So if you were lucky enough to catch yesterday, then you know that viscoelastic word. You probably had dreams about it because we talked about it so much. But you're going to take that OD, temporarily reduce it, and then after it's pulled into the pipe, it's allowed to relax and forcibly pushes up against that pipe. So there'll be no annular space, and we'll maintain the largest ID possible with that process. It's really cool. We've done it on show floors before for AWWA, their annual conference and exhibition, and it is just eye-opening to see what this material type will do. So Steve with 6Es, this is you on valves here. I love to talk about valves too, but Steve does as well. So I'll take a break now.
Thank you, Alan. So Alan shared with you the different ways to install HDPE, open cut, slip lining, pipe bursting, but of course we have to connect to existing infrastructure and existing materials. One of those main items is the gate valve. So these gate valves have been around for years, and in our industry, the waterworks industry, it's a mechanical joint gate valve where you use bolts and a gland to compress a gasket. So back in the 90s, I believe, a guy named Harvey Sletnick invented the MJ adapter. This MJ adapter allows HDPE to be connected to these mechanical joints. There's a MJ gasket on the spigot end of that mechanical joint adapter. Run the bolts in, tighten it up, pulls the MJ adapter into the valve, allowing that gasket to compress, and it's sealing that joint. So that way we can adapt to existing and legacy products with HDPE. So this MJ adapter is fused on to the end of the pipe, and it is drawn into the valve to make the joint. Next slide. So a little better detail of that. Little video. Yep. So, but since the 90s, when we started adapting to these, because our spec came out in the early 90s, AWWA C906, the MJ adapter was the way to go. It was the way to connect to existing infrastructure and existing waterworks products. Since then, there's been a lot of innovation. One of the great innovations is this hydraulically pressed on HDPE onto the end of the valve. So they made the end of the valve a barbed fitting, and it's hydraulically pressed onto the end of the valve, and then a follower ring, you can see in the right-hand picture, is pressed over that, so it creates a fully restrained joint. And this same valve technology is, the internal workings of the valve work the same as an MJ valve. It just has a different end that's adapted specifically for HDPE pipe, and those ends can come in with different DR ratings. Typically it's DR11 for the water industry, but that is a great innovation that came about in the last 5 or 10 years. And there are other manufacturers that have the same technology. So that's made specific for HDPE. And we have a limit to the size that they're doing those in our industry, but another innovation that's happened over the years is the ball valves that came from the gas industry, because they use ball valves throughout the gas distribution industry, and they kind of were our guinea pig back in the 80s, and then in the 90s our industry adapted to the water industry, getting all our AWWA and NSF certifications to use in potable water systems. But today there's even these ball valves that come in up to 16-inch, but there's a lot of manufacturers that go all the way up to 12-inch. So these ball valves are made of HDPE, so you eliminate the bolts and the corrosion opportunities, and you get a full flow. So it's a great option for you when you're integrating HDPE into your water system. So the ball valves are yet another option. The one thing in the water industry that everyone actually sees is a fire hydrant. I like to tell people, it's like the only thing that we sell that you get to see is a fire hydrant. That's our access to water to obviously fight fires, for one, but water systems and water departments use them all the time to flush and clean their lines. So our industry needed to have a way to adapt to that. Of course, the MJ adapter is was the first and the most common way to adapt to those products, because it's just a mechanical joint fitting at the shoe of the gate valve. But also there have been a lot of innovations, and they put that barbed AVK, the valve you saw earlier being pressed on, they also give that option to have HDPE pressed on to the shoe of the valve. So then all the contractor has to do is fuse that HDPE end onto the hydrant lead. And that allows HDPE to be integrated into a system and still use legacy products like the fire hydrant. Service connections obviously are, that's why you're putting a water system in the first place. There's all kinds of, we have different size services. If you're going into a commercial building like a Walmart, it might be let's say a 6-inch service lead that goes to a large commercial building. This gentleman is tapping, I'm assuming that's not a live main, since he's not going through a tap machine or a valve. So he's actually coring a hole in the side of the pipe. That electrofusion saddle for that 6-inch service saddle was electrofused onto the side of the pipe. And now that that's done cooling, he is now core drilling that hole. So you can avoid putting an actual T fitting in the middle of the line. You can add it later. But this, of course, he's got an MJ adapter on there. So after he's done coring that, he'll bolt on a MJ gate valve to provide isolation for that commercial service line.
Steve, I can confirm that was not a live line. So this is a unique scenario up in Duluth, Minnesota, to which they have a larger service line going into a bigger building in the basement of it. So that fitting there is inserted in to make sure that keeping the HDPE centered and in the basement of the building. So yep, that he'd get a whole lot of water on him if that was.
Good. I'm glad to hear he's working in a safe trench. So service lines are obviously not always that large. There's all kinds of options you can use to cross a road, for instance, to get to the other side of the road to what we call the long services. Because HDPE is so flexible, you can have it pull behind your augering tool, or in this case on the right, it's what at least my contractor is always called a hole hog. And it's a pneumatic device that basically has a hammer on the front, and it taps its way through the ground under the road. Usually goes straight, probably 90% of the time it goes straight and ends up on the other side of the road, and it's pulling the HDPE behind it to and then we once the service line is pulled across the road, then you go and attach it to the curb stop on the customer side, or the court stop on the water main side. And on cue, there is a corp stop that's threaded into what is a HDPE service saddle. So this is a electrofusion saddle, which is different than a mechanical saddle, which they use on other piping products like PVC, and sometimes they use mechanical saddles that have a gasket in them. That service saddle on the left is fused on to the outside of the pipe. So you have a leak-free fusion joint on the water main, and then you thread the corporation stop, which is used to tap through. So you can do a live tap if you have a corporation stop, which is that brass fitting there. But you would attach a tap machine to that, open up the valve, core through the main, and then hook up your service lateral. An item that we've used for probably 40 years in the gas industry is on your right, and that is a electrofusion tapping tee. It's got the tapper is built into it under that cap, and it's got a stainless steel cutter that can then cut down through the top of the pipe after that is electrofused onto the pipe. He's hooking up the service lateral before he does that with a small butt fusion machine. So he's actually fusing the pipe to the outlet of that tapping tee. That allows leak-free system, and you can avoid then using legacy products like mechanical brass couplings or that corp stop. So
So
that's
one of the reasons why we show both of these together, Steve, is there's so many different ways that you could make a service connection. If we were at a road show, we'd have a whole table set up for all the different methods, and most municipalities there have whatever it is that they prefer, spec'd and tried and true, and then maintain an inventory with all this. But the HDPE industry understands that and is innovated to make lots of different fittings available just for that. So Pete, I think, wants to shed some light too.
Yeah, so Alan, in May, we're going to have our first demo day in 2 years virtually. So we're going to go to Tulsa to McElroy's Technical Center, and we're going to do a demo day. And one of our 20-minute demos is going to be how to connect to the main. So we're going to illustrate this live for our audience. Alan, we just got a question, which we get a lot, where people are commenting that state departments of transportation don't really like polyethylene. In this case, the person that asked the question anonymously said, they say it's going to pull out from whatever it's connected to. So what is the logical response to an unknowledgeable person, an ignorant person on how polyethylene works, says, oh, your pipe is terrible, it pulls out or whatever it is and it breaks. Therefore, it's the polyethylene's fault.
Okay, well, I'm going to take a big overreach on some of this, Pete, and say Department of Transportation's oftentimes, in my personal history and experience, aren't always that good at installing pressure pipe. So there's an educational element about just about everything when we work with DOT or other agencies. The fitting or smaller diameter service line, what it's attached to, and this is a perfect time to talk about it in service connections. We want to make sure that it is attached in the appropriate manner and done correctly. So the industry itself, from gas, now failure in gas mains means something a little bit different than failure in potable water mains, and the fact that houses blow up and people die and things like that. And water would just lose a little bit of water for a leak of this nature, but they are fusing from end to end with all polyethylene, which is called a monolithic system. And they do that quite a bit because they don't want any of that leak. And there's not litigation, there's legislation that requires them to inspect gas mains all throughout their system as well. Unfortunately for water mains, we don't have that legislative support quite there yet. But one thing I can say is DOT needs to be educated from the municipalities on exactly what these failures are, and certainly be taught not to preclude PE pipe. Dan, Mr. Landy, you'd like to share something too.
Yeah, one of the things that you taught me, I'm passing it on in the Q&A section today, is that the soils will actually restrain the pipe for the most part. So you're going to have that initial thermal equilibrium where the pipe expands and contracts and comes to its final resting place. But then the soil from that point forward will restrain most expansion and contraction, correct? Could you expand upon that? Because we have a few questions on that today. Thanks.
Yeah, absolutely. Temperature fluctuation does affect high density polyethylene. For the most part, where we're going to look at temperature fluctuation and have to do some detailed analysis is in an above ground application, or when we're moving the pipe from above ground to in the ground where we know there's going to be change in temperature. Typically, any change in temperature due to thermal conditions doesn't penetrate too far into the soil, except for obviously when we have a freeze-thaw zone, and burial depths across the country are going to change. We wouldn't bury potable water main in Florida like you would at the same depth in Minnesota. That's because there's a freeze-thaw cycle in that manner. So high-density polyethylene is flexible enough that if the water within the pipe, let's say it's stagnant, so we have no movement, does freeze, the HDPE will expand and actually will not break. That's not to say the fitting that it's attached to, if there is a fitting, won't break itself, but the high density polyethylene typically will not. So it's important to be buried underneath that frost line, and using high density polyethylene. That soil surrounding it will restrain it from doing just that. So I hope that was good enough of an explanation, and we're going to turn it right back over to Steve with 6 E's.
And I think, thank you, Alan. I think it's important to realize on the restraint question and the DOT question that usually the reason DOT might resist using polyethylene, it's from one bad experience because somebody installed, forgot to restrain the end of a road crossing, didn't use an MJ adapter to restrain into their transition back to another product. And then they had that one bad memory where it was really a contractor install issue. It's not a HDPE pipe issue. It's somebody didn't know that they needed to restrain the ends of that road crossing. And then they have a hard time forgetting that, hey, wait, that was a contractor error, not a polyethylene pipe problem. It was maybe not having the right standard detail problem and showing them how to restrain to other piping products that are restrained differently. So anyway, back to the show. I forget this gentleman's name, but I'm told I believe Peter
Dante
mentioned, yeah, Dante. Peter has confirmed that he's all right, that he survived this event. But this will not happen with HDPE. It does not fracture catastrophically like PVC will do. And that, you know, and PVC generally won't do that, but if you don't have your drill bit properly sharpened, it can fragment like this. Polyethylene resin is much more malleable than PVC, and it will not fracture in this way. So it's just something that anybody who's installed PVC pipe before, they know they've had that experience because their tap bit wasn't sharp enough or whatever, and that just flat out will not happen with HDPE because of its flexibility. So what makes PVC really different than other water products or other piping products in the waterworks industry is that we join our pipe not with gaskets but with fusion, and one of those types of fusion is electrofusion, and it's all fusion is heat, pressure, and time. And the electrofusion gets its source of heat from heat resistant wires that are built into the fittings. And where it gets its pressure is it has these 3 cold zones on either side of the wires that are built into the profiles of a coupling. And the tapping saddle on the right has the wires on the inside radius of the corp saddle that you see there. And the cold zones prevent when the molten material starts to heat up, and when anything heats up, it expands. It tries to escape. It dams up in the cold zones and builds pressure, and the pressure buildup makes the molecules from the outside of the pipe mix with the molecules that are melted from the inside of the coupling. There's a certain time that electrofusion process happens, and it's all programmed into the electrofusion processor, and it knows how long to cook that fitting, so to speak, to the correct amount of time. Once the process is complete and the heat stops, then the cool down process happens, and that's a certain amount of time. But once that happens, that fusion joint is stronger than the pipe itself, and it's a 100% leak-free connection. So electrofusion comes in all sorts of, the most common are the tapping saddles you see there, or the coupling that you see on the left. And again, you've eliminated the corporation stop, the brass fitting, which, I mean, a 1-inch corporation stop is over $100, and that's just the valve, and you only use that one time, and that's to do the hot tap. These electrofusion tap keys are closer to $30, and you don't have the cost of a mechanical saddle, so it's a much more economical way to do a service tap for a water department than doing it with mechanical fittings. Because our industry has evolved so much over the years, they came up with all these municipal advisory board was formed, and these are basically municipalities who had adopted HDPE over the years. The board got together, and so it's a group of multiple municipalities from all over the United States. One in my area, I live in Ohio. One of the members is from Fort Wayne, Indiana, which is a real big advocate of HDPE. He was on this advisory board, so they all got together and came up with a generic procedure that they want to do that applies to water departments specifically, and they came up with generic procedures for doing electrofusion. So now you're no longer necessarily reliant on the individual manufacturers of HDPE electrofusion fittings. So they have all these different suggestions, and they're on PPI and the PE Alliance's website, that you can have these procedures already written for you, and they're there to share for your municipalities that you're advising. So it just goes through the process of how you do electrofusion procedurally, and this jives with all the manufacturers of electrofusion products. You just got to clean the pipe, you mark it so you know where you're going to scrape it, and the lower left there is the pipe peeler, so it peels off the oxidative layer that's on the outside of the pipe, because you don't want any contamination within the fusion zone. So it's very important to clean the pipe, scrape it properly, and then you mark the pipe because you want to center, make sure the coupling is centered over the joint between the two pipes. The heat is applied by the electrofusion processor after you've clamped it to make sure you got proper alignment, and the fusion process begins. The heat melts the inside of the coupling and the outside of the pipe, that the pressure builds, the molecules mix, and electrofusion is made. And again, it's stronger than the pipe itself. Here's a live version of that. See how the color changed, how the kind of little bit of milky white look on the outside of the pipe disappeared when you scraped it. It became really shiny, and that's down to virgin resin. There was no there's no oxidative layer on the outside of the pipe now once you've peeled it. They leave the bag on the coupling to keep any dirt or other contaminants from getting in there. See the line that he has marked, so he knows that it's centered. Plugs in the electrofusion processor, which will do any coupling of any brand. They share their barcodes. He barcodes it, and that's what, a 279 second burn. So it's gonna heat those coils up for 279 seconds for that particular size coupling. So that's electrofusion, and that really does make HDPE unique compared to other municipal water products, piping products, I should say.
So they do make service lines, Steve, with some tracer wires we're seeing here. Now, plastic pipe, of course, is not does not carry an electrical conduit or conductivity. That was hard for me to say. So we do need to try to put tracer wires, RFID ball, which actually sends a signal to the surface to locate it. And these are just some methods in order to be able to properly locate this when we're trying to figure out where it is to make that repair in the field in that manner. So those are just some simple things there. Here's more service connections. Go ahead, Steve. I'm sorry.
No, that's fine. It's an interesting thing about that tracer wire is it is also coated in, guess what, HDPE. So, if you're specifying tracer wire, you want to make sure You do it for buried use, and all the buried use tracer wire brands have a HDPE coating, and so that protects the tracer wire just like it protects your pipe from corrosion.
We are moving a little bit behind, so I'm going to
Okay.
just speed
No.
through some of these next ones.
Yep.
So
Just more
these series
examples.
of slides itself will show you that HDPE has just about any option for you to integrate into your water system. This is a pipe display that we carry with us and reassemble at each location as we go, and we just show you just how many different ways we can actually put this high-density polyethylene together in your system. So some of those old arguments that you have to you can't use this fitting or that fitting or the other one. There's always a fitting that Steve has right there in Ohio and Core and Maine and all the states that he has, and can deliver right to you there. So here's some more cut sheets. They do have shop drawing submittals that they'll send with all the information on this to be able to adopt into your system. It'll tell you the exact details just in case you're interested as to how big that fitting is, what the dimensions are, and also for IPS, iron pipe size, or DIPS, ductile iron pipe size, as we go through. So this shows the strength of that fusion. So they fused an electrofusion fitting right onto a polyethylene pipe, and now we are lifting the forklift with a crane system in a manufacturing facility. So
Not in the United States.
probably not, but
I don't think that.
when he says that the joint is as strong, if not stronger, than the pipe itself, he certainly isn't lying in that manner. Okay, so
The point I wanted, the point I wanted to make on this, on these compression fittings, is the brass fittings, the corp stop there in brass, that's a compression fitting that was originally made for copper. It'll also work on HDPE as long as you have the right OD, but you definitely need a stainless steel stiffener inside the pipe to resist that compressive force. Now, the ones on the left, the black polypropylene fittings, those are also designed for HDPE and were used in the rescue, the mine rescue in Thailand, to get the water out of that mine. You couldn't fuse in that situation because you can't have water in the fusion zone. So they use those compression fittings on the left, which work great and are stocked at all distributors across the United States, but they do not need a stainless steel stiffener because they are not sealed by compression. They're sealed by an O-ring. And so when the pressure is put on the pipe, that O-ring expands into the wall, into the exterior wall of the pipe. And so the higher the pressure, the more that O-ring is forced in there. So they do not. So the more legacy compression fittings that are made of brass, they do need a stiffener, but the newer polypropylene plastic compression fittings do not need a stainless steel stiffener because there is no exterior compression force placed on the pipe. Of course, our industry, because our pipes are longer and they come in coils, there's material handling suggestions from PPI, the industry trade group. So there's manuals on how to handle the pipe safely throughout PPI's website. We can get you those as well. I think the next slide, Alan, is a way not to unload the pipe, but our pipe is so durable that people do unload pipe this way. This is at a gravel quarry, so but they use our pipe for sand slurries on at sand and gravel mines. So they've been using our pipe for years because the abrasion resistance is so much better than steel. It's 4 times that of steel. But because of its durability, they feel like they can treat it this way. Now the pipe doesn't break and the pipe is absolutely fine, but that is not a safe way to unload HDPE pipe. Here is the way you should be doing it. And this is not only a better way to handle the pipe, but it's also more productive when you set up your 40-foot lengths, or these might be 50s. to set them in your butt fusion machine to butt fuse the pipe with McElroy equipment. Our fusion machines get up to very large sizes. This is a T900. It's remote controlled. T900 that's 900 millimeters, so it goes up to 36-inch pipe. And there's even larger fusion machines, but these are some of the innovations that have happened in the pipe industry over the years as we've gotten to larger and larger pipes. McElroy is the leader in fusion equipment and one of the founders of this organization. And they have just developed new and innovative productivity features into their fusion equipment over the years.
Absolutely, Steve. One of the best things that I've seen is just this sheer amount of innovation that happens in this industry to make things easier. Every time I put my hand on a McElroy machine, I get to a point where, oh, it should do that. And then they say, no, it does that. It's right there. That's it. So we just had a really good question from Dan Sirkin, and Peter probably will come on too to be able to do this. It's a rather complicated one. And we've got some of the right people here to try to talk through it. Sometimes municipalities are used to doing and installing other pipe material types, and they have the equipment to do it. They don't have high density polyethylene equipment such as fusion machines or electrofusion machines, and there's a learning curve. So how is it that we encourage some of those municipalities to switch and embrace high density polyethylene to teach them? How do we get them over that line? And Dan, I think one of the reasons why we pulled focus on your question is part of the reason why Peter, Steve, and I have jobs. So here it is. Would you guys like to elaborate on some of this?
I'll give it a shot real quick. I had the same question yesterday, so that's why I'm bringing this up. I did a lunch and learn at an engineering firm yesterday. There were 15 people there. Somebody had the exact same question, and what we see happening is you get a whole different group of contractors bidding a polyethylene job. The contractors are out there, they're just installing gas pipe right now. So there's people out there that have all the experience on fusion, own the equipment, have been doing it for 30 or 40 years, but they're working for the gas company. And so a lot of times you'll see a different crowd of contractors bid a polyethylene force main job, for instance. So that's one way that I've seen when somebody specifies HDPE, they get a different set of contractors that bid it, the people that already own the equipment, the people that have the experience. Because if you can lay gas pipe, you can lay water pipe.
Yeah, Dan, we hear this question all the time, or statement as to why the adoption. Polyethylene only has a 15% market share in North America, whereas PVC is like 50% and ductile has the rest. 30 years ago, 66% of the pipe going in the ground was metal pipe. Today, 66% is plastic pipe, whether it's PVC or polyethylene. I served on a board for 10 years in a town. And if I had my chief engineer come to me and say, I don't want to use a better product because I don't want to teach my guys how to do it, I would get a new chief engineer. Or I would be concerned about my organization's ability or interest in solving for the failure mechanisms that we all see every day. There's a reason Houston is very worried about their concrete pipes. Their large diameter concrete pipes are all at the end of their life now, and they're starting to fail on a more regular basis. But Dan, I look at it more like there's a certain population of municipalities and consulting civils that are willing to accept intellectual arguments about our selling proposition. Our selling proposition is we solve for the failure mechanisms of other material. And if there's a utility that doesn't want to use it because they don't want to train up their staff and learn something new, fine, I'll move on to the next one, because there is, we're moving up and to the right really very quickly, very well. In other words, we're selling more and more pipe every year. Last year, we put in 19,000 miles of polyethylene pipe in US and Canadian water utilities. So it's a complicated question. There's a lot going on. It goes to the issue of organizational behavior, goes to the issue of training, looking at the long horizon of what utilities maintenance budgets look like and their capital programs. So it's a great question. It's something that we face all the time, and I appreciate your asking it. Back to you, Alan. Let's pick up some time.
You
Great
got
job,
it.
Stephen.
So part of the reason why we're here is to teach you guys how to fix your infrastructure as well. So we just need to get those projects and stuff going on off the ground. So definitely we're here to do lots of different things. Inventory yard. A unique thing about high density polyethylene here is the fact that it is UV resistant. So the carbon black that we've got, 2% of the resin is integrated with carbon black, and that makes it so we're diffusing that UV radiation through the wall of the actual pipe itself. So it does heat up during the day. And for those of you that are asking about temperature, we'd have a temperature increase in expansion of that material. So we were going to be looking at, especially during pressure testing, if that pipe has expanded, then it'll take on more allowable water to go through there. And so that expansion will have to be tracked when we are pressure testing the pipe. But it is permanently UV resistant, which is great for our inventory yards. So when we're in the inventory yard, that HDPE pipe is never going to degrade in that manner. Obviously, electrofusion fittings you want to keep in the bag in a controlled area itself. But here we're not going to have a denigrated pipe like PVC or gaskets or other things in order to be able to face that problem as we go through. So water pipe materials over time, and this speaks to some of what Dan was asking as well. And we love the questions, by the way. Your questions make everything better. So that's what Dan Landy, Aaron, and Matt Hahn are covering for us. So the way that we are installing pipe is very different than it was a long time ago, and also very different than when PVC, ductile iron, and HDPE were all invented, which was in the 60s. Just so happens the municipal potable water market isn't as familiar because gas is where quite a bit of high density polyethylene was installed, way more so than potable water in the mix. But here's basically what this pipe is. We've talked already about thermoplastics a bit. This process that you're watching of fusion makes a bond that basically stronger than the pipe itself. All we're doing is we are controlling how this high density polyethylene resin flows on a molecular level. It's very amazing. So if we control that environment, doesn't matter what type of fusion that you're doing, it's going to be just like extruding the pipe itself in the manufacturing facility. So here's the steps to butt fusion. So we are going to clean it, shave it, heat it, and fuse it. When you're using butt fusion, that machine will do quite a bit of this for you. So all you'll have to do is load it right up there. And as you saw from the productivity tools, one employee can come through and fuse up a very long run in advance, while all of the other employees, workers, are out there trying to find third-party utilities, trying to put in service connections, do all sorts of other things, while this particular individual maintains that productivity level as we go through. So there are guidance, technical notes. This is one, technical note 51 for butt fusion. Tell you through the whole process, walk you through it, show what could go wrong in different manners and what to look for as we're coming along through this. The allowable bend radius of high density polyethylene is more forgiving than any other pipe material type, and that's because of that durability and the ruggedness that we attribute to that viscoelastic behavior of high density polyethylene. So here's just some information generally on the allowable bending radius. When we look towards trenchless technologies, we're not limited by the bend radius of high density polyethylene, but more so by the bend radius of the equipment, such as drill string or quick lock rods in terms of pipe bursting. So it is very forgiving to be able to come through and manipulate this pipe in the field during that installation. DIP and PVC have that same bend radius, but they'll achieve it by deflecting the joint itself. So some of the most common failures upon installation for DIP and PVC are going to be over deflection and over insertion of that bell and spigot pipe, where we'll break that as well. So these can either show up immediately or within the first several years of operation. So when we get to ease of workability, we are going to take a dry chainsaw, oilless chainsaw, out in the field to be able to cut that pipe. Then you can just refuse that pipe right there. You can use also a sawzall, which you'll see in the other picture as well. So it's very easy to work with this pipe in the field and very durable. When we're moving it from the laydown yard to the actual location, it's very common to just drag it on the surface. This isn't damaging the pipe typically beyond its allowable 10% gouge allowance, but we do, as construction inspectors, want to walk that pipe before insertion once it is at the pipe insertion pit to be able to see if something along the pipe's journey from the laydown yard to the actual insertion pit has put in a big gouge for it. So here's just some more information, basically more images on over insertion and proper tapping for us. Again, we do need to bury that pipe, the bell and spigot pipe, as we go through. This picture on the right, as they're banging in that pipe, they're further applying stress to the upstream pipes that had already been inserted into their bell and spigot segments as well. Here's a video for flushing and pigging. So after we install, we are going to tie in on one side. We will put a pig and potentially chlorinated water, chlorine tablets or the like, on the opposite side of the pig. Tie into a fire hydrant, open that fire hydrant, basically flush that pipe out from any debris or contaminant in it. You absolutely want to make sure that if there is superchlorinated water, that we are dechlorinating that water as we're retrieving it. And Steve would definitely like to add something to that process here.
Yeah, so many municipalities already pig their larger lines, and they need to do it because they get so much more dirt in their pipe, they get stone in their pipe, and you don't get enough velocity without a pig to rinse out larger diameter pipes. So this is not unique to polyethylene. You do it in a lot of municipalities require pigging before they turn the line over. In our case, it can get any shavings that might be still left in the pipe from the fusion process.
So none of that hurts the pipe as it comes through. Those foam pigs are simply scraping the inside. Similar process if we're preparing an existing pipeline for rehabilitation via slip lining, we're preparing the inside surface of that pipe itself. So here's a standard on leak testing. Essentially, ASTM allows us to do that. What's unique to high-density polyethylene itself is the fact that, as I mentioned in the sun, it will expand. So polyethylene is a leak-free system, and typically, if it's stable and calibrated and not expanding at that time, you will not add any makeup water to it. So that's just one of the unique things that we pay attention to during that leak testing. What you'll see here is a laydown yard with some pipe strings that have been strung out. Equally, we'll disinfect the pipe while pressure testing that pipe. We'll make sure that we pressure test for less than 8 hours, which is fairly typical. And again, note each operating pressure of the municipality may be different from your operating pressure at the pipe. And we want to make sure to be respectful of that when we are doing our pressure tests. So Steve, you want to talk about in the trenches butt fusion?
Yeah, back to the innovation that McElroy, the largest and only domestic fusion machine manufacturer, has done over the years. As we've gone to bigger and more complicated projects, they've developed great equipment features that allow you to take that butt fusion machine down into the ditch with extension hoses to do, in this case, very large diameter in ditch butt fusions. The one thing about butt fusion, unlike using electrofusion couplings, is one of the pipes has to be able to move. So one of these two pipes is free to move to do the butt fusion. It needs to move about the thickness of that facer, which is, in that case, was about 8 inches thick.
So we did talk through quite a bit of this and answering Dan's question previously, just some more photographs and animated GIFs of contractors that are out there doing the work. There are people out there doing it. They do know about productivity tools. Oftentimes when we discover polyethylene and how productive we can be by using it, we will breeze right through this process and go right straight to productivity and putting in pipe. So Steve's company can also fabricate fittings for you. So if you know that you need a special fitting, or if you know that you need a special bend radius, they will put it together in their field, in their yard for you, and be able to get it to your site. So here's another video. Municipal in-house construction. Pete, I think you're talking over this one, if you like.
Hi, yeah, that video we shot up in Austin, Minnesota, Alan, and we're just showing about this utility south of Minneapolis has incorporated their own staff. Since they've been using poly so long, they're not fixing as much pipe anymore, so they just take those same guys, kind of like the Maytag repairman thing, and they've taught them how to install polyethylene.
Easy enough. Crew training, we're doing it right now. We do it all the time, and so does Steve's crew. As you'll start to embark upon your polyethylene journey, we will come to you or tell you where we're going to be able to have that training and to be able to move forward and make that training happen for you. So it happens on all levels, all different sizes of pipe. We'll be more than happy to bring equipment to your location or tell you exactly where we're going to be to do that. So here's a unique thing from the gas industry as it comes over. You can squeeze this pipe off. So that's during the middle of the night in gas main repair. They would simply squeeze that pipe off in locations, perform the repair, and then relieve or open up that pipe through it. Now, there are controls as to how quickly you could go down and then come back up for that pipe to be considered exactly as it was before. It does not damage the pipe if we do squeeze it down within that control limit. If you happen to be in a hurry and you do it faster and damage the pipe there, you're probably not going to permanently damage it. We just put a repair clamp on it or come back and fix that at a later date as we go through. So here's what it tells you for a 16-inch DR11 pipe. It'll take 6.5 minutes to squeeze it down, 12.5 minutes to squeeze it up, and they've got plenty of guidance for you on that. That MAB board that Stephen mentioned also has repair options. So they'll walk you through a big key resource here. You can buy this as a protected book for you, so that way the crew person can take it in the truck for you while they're making the repair, and it has a decision tree matrix here for you in order to be able to steer you in the right direction as to what repair to do at what time. So here's an example of a sidewall fusion itself coming in and doing a new repair for us. We are looking at repair clamps that can be considered permanent now as well. Those are more stout, heavy duty repair clamps as we get through that. Here's some more images of the in-ditch butt fusion that Steve had talked about, and he'll add some more color right now.
Yeah, so this is that innovation that McElroy has done over the years to be able to remove those jaws and lower them down safely into the ditch to make a butt fusion. Now, again, like I said before, one of the two sides has to be moved to do a butt fusion. If you go to the next slide, you'll see how you would do a repair when you can't move either side, because when both ends are buried, right, you can't move the pipe. So that's when you go to electrofusion, properly scrape the pipe. whatever third-party damage happened in between those two couplings. You replace it with new pipe and then electrofuse the two joints on either side, because you couldn't move both sides or one side of the pipe.
All right, this is another video we've got for you. So part of what we do here at the Alliance for PE Pipe is to tell your stories.
It's had a positive impact on our capital
Pete,
program.
come on and
Areas
add
that
some more
we've
color.
had multiple breaks in, those areas are now been eliminated. We've reduced our main break rate drastically. Our unaccounted for water has dropped drastically. We find it's been a very positive towards our bottom line.
It's Richard Brand from East Windsor, New Jersey, Municipal
Correct.
Utility.
Our field crews now have been out doing other maintenance projects other than doing emergency main repairs.
Yeah, so now the final part, well, that's all right. So then let's go to Austin, Minnesota. Here's a great example, Steve, one of your colleagues, Tom Gannon, up there in Austin. These guys have been doing a lot of their own work. This is that image that we saw before, that little video. So they're doing open cut, drilling, and pipe bursting every year. That I call it slash and burn on the open cut, because they come in and they do all the utilities at the same time. So gas, water, drainage, the road, wastewater, all those utilities and those services are done at the same time. Go to the next slide, Ellen. So this is that open cut image of putting in a 300-foot piece. What was done yesterday is in the lower right now. Now we're putting in another 300-foot piece, and it will be butt fused in the trench. And so they do about 300 feet a day for water. Go ahead, Alan. And then finally, the way they like to connect to the main that they put in is with the sidewall fusion method. That's the third fusion. So those are self-tapping tees using the sidewall method, which is very common in the gas industry. Probably fewer than 10% of utilities do it in water, but it's a great fusion. It works really well. And so he did one fusion going off to the west. Now that next fusion he's doing is going to go off to the east. And then he used butt fusion to connect to that service saddle. The next video that we're going to look at is a friend of mine, Josh Van Diver, who's with Redding, California. So think north of Sacramento, not about an hour and a half away from Eureka, that just had that earthquake.
20 or 40 foot
and they
joints
use it
that are
for
welded
wastewater.
to make a seamless pipe. It's like pulling a hose through. You never have to see again. And coming from a maintenance standpoint, where you have those failure points of joints where roots and I&I and everything can get in, eliminating that eliminates the need to ever have to go back. The impact that Poly's had on our capital plan is huge. We pretty much have changed our entire capital improvement process on the sewer collection side to replace pipe that needs bigger diameter. If we need more capacity, we burst it. And the reason why is because we can get away with a lot less open cut and the cover costs and paving costs and all that. Begin introduced to polypipe and the whole bursting process of what you can actually do. I think if more collection systems, water agencies, and municipalities in general could start to look at the newer technologies that are out there, they're going to really be able to get a lot done.
Yeah, so they use it for AC pipe
Putting in this
to burst that, and they also use it for clay. Now this engineer I met down in Sunrise, Florida, so think Fort Lauderdale, they provide water and wastewater to 7 different cities in the area. He learned something very interesting.
We just bid out a project at the Escape Valencia community of the town of Davie here in Broward County, Florida. And the project consists of about 40 to 45,000 feet of pipe. Including that in our contract, with an alternate bid for HDPE, we were able to save between $2 and $3 million by making that transition on this project.
Yeah, so that was a transition from open cut to pipe bursting. And that was the first time they'd done a pipe bursting job, Alan. Really very exciting. Now, off to Castleberry, Florida, a little bit further north than Sunrise.
So in Castleberry, when I was there, we were lucky enough, blessed to be able to get money from the American Recovery and Reinvestment Act. And we replaced 35 miles of aging AC pipe via pipe bursting method. So basically, we replaced all that AC pipe within the city limits. We did use $10 million in federal grant. Federal government really helped accelerate that program itself. And as you can see here, HDPE, the crews really did learn how to take advantage of that viscoelastic behavior and avoid curves and bends or manufactured fittings to accomplish that bend for it there. So that one did use static pipe bursting. Here's just another video of the process itself of pulling back on the pipe. So we've pushed that static rod into the pipe. We've connected to an expander head, and we're pulling back through that process itself. It's pretty basic as we go through. It's kind of like watching paint dry after you've seen it enough times, but a very useful method to be able to handle that pipe and replace that existing pipe through it. So this is an example, a video of AC pipe being burst and the fragments that just are created and then left in the soil surrounding that replacement pipe. It can be done safely. We've done lots of negative exposure assessments to make sure that the crew itself is safe while they are bursting that pipe, and no fragments of air is damaged with asbestos particles as we go through. So here's another example of pulling a pipe from a laydown yard into place as we're moving that pipeline from the laydown yard to where we were lining up with the expander head and the pipe insertion pit. So you're seeing how they take advantage of that durability and ruggedness of high density polyethylene to be able to make that. So some of the direct success we've had with the Alliance in helping agencies, the Lake Kiowa Special Utility District north of Dallas has bid a AC pipe bursting project, and they're starting to embark upon it. Now that we've done seminars with this crew and helped write specifications, and then also looked at design as design reviews as that advanced, and they're starting that project through it. So we'd love to help you with your project. Dan, Aaron, Pete, and I love to talk about polyethylene projects all the time. So definitely don't hesitate to give us a call and question. Duluth, Minnesota, they fully integrated it into their capital plan. Another story, of course, of learning from the gas side and then coming on over to the municipal water side. Pete, did you have something you wanted to add?
Sure. Go ahead to the next slide. What's really exciting about Eric Schaefer's work here is he does a water job. He does water, sewer, both pipe bursting and drilling every year, as well as an open cut. And that's where you saw these earlier examples. Next slide. Eric also serves on the Municipal Advisory Board at the Plastics Pipe Institute. Let's hear what he had to say on one of my podcasts. What were some of the issues the city was seeing in its conveyance of water from A to B?
Big things are corrosion and leaks. Over time, a number of leaks and water main breaks we had each year just kept spiraling up and up. And we defined a leak as a water coming out of the pipe that we can fix anytime we get to it, where a break is something we call an emergency and fix it right now. But we got as high as about 160 leaks and 160 breaks, or a total of 320 holes in the ground up in 1 year. Now we're trending back down finally now. But that's because we've gone out and focused on the worst neighborhoods. We've pulled out the cast iron and the ductile iron and stuck in polyethylene, and we just don't have the failures anymore.
So you used to see at most 320 a year. What are you looking at now on an annual basis?
Last year we had 127 leaks and breaks combined.
Wow, so you've cut it to a third.
We cut it to a third, but some of that's affected by temperature. I can't take all the credit.
But you had some breaks. Were they in polyethylene or are they in traditional materials?
Traditional materials. Yeah, we don't have breaks in polyethylene.
So that Municipal Advisory Board is a group comprised of municipal leaders that have adopted polyethylene to a certain level. Great resource. Eric has said, as Richard Brand has said, that they will talk to anybody with any question at any time. Back to you, Alan.
Great. The East Bay Mud has adopted polyethylene projects. These are a primary example of how to take advantage of that allowable bending radius and using to be able to get polyethylene where you need it. This is a fault zone, an area as to which they are seismic activity. It's a older neighborhood as to which the switchbacks were pretty severe. As you could see from these, the helicopter, yes, it did fly polyethylene right there to the job site as it goes through. So the site constraints are fairly severe, as to which they needed to be able to install this high density polyethylene, and the project was a resounding success as they come through. Hi, Noah, good to see you. And as we come through here, we'll talk some more about some resources for us. We've got just a few more minutes. Maybe Pete, Steve, if you guys want to both come on and talk us through this.
Okay.
I'll
I'd be
answer
happy
a question from Amy Cook.
Yeah, so just send Dan or Aaron a request for some of the information. Go to the next slide. And we can send, sample specs. We can send the engineer's package to you. You heard it here that Alan and the guys are committed to putting out a new version of the engineer's package this year with updated information. So we're very excited about that. Next slide. So a lot of the information that we get comes from PPI, so the Plastics Pipe Institute. They have a book, and this book we can sell it to you, or they can sell it to you for $60, or you can get it for free as a PDF as part of the engineer's package. The great thing about the book is it is searchable. So next slide. Covers a lot of great issues. And then we also have, as Alan mentioned earlier briefly, is we have a lot of standard details, both in AutoCAD format and in traditional PDF, so that you can use. And these details cover everything from connections to other materials. Go ahead to the next slide. Connections to other materials, fire hydrants, that AVK Series 66 product. When do you restrain polyethylene? Really, you don't need to, except when you're connecting to legacy materials. So that's it. I wanted to say thank you to you all for hanging around. We only lost like 15 people here to the end on a 90-minute call. We're going to have another webinar at the end of the month with ASCE. So great job today, Alan Ambler. Great job, Steve Breedemeyer. Thank you for your guys' efforts in preparing this deck. Thank you to my audience. Hang around. I'm going to close up this webinar. And when I do that, there are a couple questions are going to come up, and you answer those, and then you tell us that you want a CEU or a PDH, and just give us 2 weeks and we will get it out to you. Alan, anything you want to add?
So we had over 40 questions, which is great. We do keep people available to answer your questions live. We did get a great question from Dan to right at the heart of the problem, which is what stops municipalities from adopting high-density polyethylene pipe? And I think we addressed that pretty well. And Steve, you shared quite a bit of personal experience in your years of selling high-density polyethylene pipe to the distribution and collection entity. And I think it was a pretty good webinar for us here. I think we did quite a bit. So what do you, any last words there, Steve?
Just thanks for wanting to learn more about HDPE. I've thought, I've sold all the products that are on that are used in municipalities, but I really feel like this is the best one for our application, and adoption can be resisted a little bit by the old guard at some municipalities, but I think it has a real future because it's a great product for this application. So thanks for taking the time to learn something about HDPE today.
And I'd like to thank Dan, Matt, and Aaron for being on that the bench for us to be able to answer your questions. So you guys did great. Thank you very much, everybody. Don't forget to do the survey at the end. That's the quickest and easiest way for you to be able to get your PDHs and go PEs. Let's go do that continuing education to make sure we recertify. Thank you, guys.